Okay, this is an ostentatious problem, right? So here's the bowling alley, right? It's like, whoa, oops. Sometimes it draws the wrong. Here are the bowling pins, right? Like, gotta draw a good bowling pin. Here's another bowling pin. I'm not very good at that, right? And then the bowling ball goes down there, right? Okay. And we hear the sound of impact 2.53 seconds later. So the ball is going to go down there, right? It's going to take some amount of time to travel that distance, right? 16.5 meters. And then the sound is going to come back. So we're going to have a sound wave heading back, right? And we know that the time for the ball to travel and the time for the sound wave to get back, we know that takes 2.53 seconds, right? So let's just write that down. 2.53 equals the time for the bowling ball to travel, right? Plus the time for the sound, right? Now, if we gain a little cleverness here, okay, if we gain a little cleverness, let's compartmentalize this, right? The time for the ball to travel is going to be some velocity over 16.5, right? Or 16.5 over some velocity, right? So let's figure that out. The time, actually we can't figure that out. The time for the sound, though, is easy, right? We've got the speed of sound, right? So the time for the sound is not very much time. So 16.5 meters divided by 343 meters per second. And I'm just using velocity as x over t. So therefore t is what, x over v or something like that, right? First day of school stuff. All right, so this time here is, let's figure it out, 16.5 divided by 343. That is 0.0481 and then some change seconds, right? So now we can make this a little more informed, right? 2.53 equals the time for the ball to get down there plus 0.0481 seconds. Okay? So can I do a little subtraction here? If I go this minus this, I'll get the time for the ball to travel down, right? Okay? Let's compartmentalize. Okay, so the time for the ball is going to be, I'm going to go 2.53 minus 0.0481. And I get 2.4819. Okay, so now that's the time for the ball to get down there. We're almost there. The velocity of the ball then is going to be distance over time. And that's going to be 16.5 divided by the 2.49 or 4819 seconds, right? So 16.5 divided by the answer I've got on my calculator. 6.648 meters per second, which 6.65 is that rounded to 3 digits. 6.52 is wrong. That's assuming that it spends the whole 2.53 seconds going down there, right? That's if you forget to take away this time for the sound.